Now is the keyword is two parallel lines. Okay, the keyword is two and parallel. You remember this word parallel. Okay, if P is keep a fixed distance from to a parallel line L1 and L2, then it should be the middle, which is the line parallel, and between L1 and L2. So how can I describe these 2 points? The first one is parallel to L1 and L2, and the second one is equidistant from L1 or L2, or you can write down as midpoint, or from between. Okay, or we can say midpoint of A, B, and C, D. Okay, and C, D. So and another one is now is two line, but this two line is not parallel. Okay, pay attention. From the first case is parallel line, is a pair of parallel lines, and the second case is not parallel. And now how can I find the fixed distance? Is P is here, and maybe we can find that P is here, and so on. So this is the first locus, and we have two locus, and another locus will be horizontal line here, another fixed distance, and so on. So it's have a horizontal line. So we have a two. We call it angle. We call it this locus. We call it the angle bisector because it's bisect. The angle is 2.5. And which locus is the required is according to the question. Okay. And the third one is we seldom to look at this. Is if a fixed distance with one point and one line. And we have the first point is to be the fixed distance from PQ and PF. Okay, if you have a point and a line here, maybe we have another one is here to here. Okay, and the third one maybe here, and so on. So it will becomes a, we call it parabola. Okay, or a quadratic function. And we have two cases. If the line, the case one, if the line is straight line is above the fixed point, then the parabola will call open downward. In case 2, if the line is below the point F, okay, then the parabola will becomes open upward. So these are two cases that you to figure out how can you draw a parabola. So now we go to exercise 1. So moving point P lie inside the square. Okay, pay attention, it's inside the square. So we don't have any locus outside EFGH, and equal distance from line segment EF and HG. So that means EF is here and HG is here. So that means it's a two parallel line. So therefore, just write down that it should be the middle one. This is the locus of P. And how can I describe it? Is the first one is a parallel line parallel to EF and GH. And second one is joining the midpoint of EH and FG. So we finished the first one, and second one, the figure shows a parallelogram of ABCD, a moving point Q inside again of the parallelogram, and it's equidistant from line segment AD and BC. So where's AD here and BC here, so it's also a two parallel line case. So that means the locus should be inside the parallelogram and the midpoint of AB and CD. So how can I describe it? Is the first point is parallel line parallel to AB and CD, or you can say that there is a line parallel to AB and CD. And second point is joining okay, the midpoint of AB and CD. Okay, so we finish question number 2. And question number 3, in the figure, x, y, and xz are equal. A point P moved inside the triangle. Okay, now it's inside the triangle. It's equal distance from x, y, and xz. So that means it's 2 intersect line. So it should be the angle bisector. So describe the locus and sketch the locus. So now is xy here and xz here. So it should be the angle bisector of yxz, which is the locus of P. So how can I describe this? Is the first one is the angle bisector of angle zxy. This first one, and second one is the line inside triangle xyz. And question number 4, the figure shows its rhombus. Okay, we never mind any figures of it. And now point P is inside the rhombus, okay, and equal distance from AD and CD. So AD, where is AD here, and CD here. So it's also a 2 intersect line. So that means it should be angle bisector of AD and CD. So let's try to write down in here. It should be angle bisector here. So therefore, the locus of P. How to describe it is the first point is a angle bisector of angle ADC. This is the first point. And the second point is inside ABCD. Okay, this is the second point. So we finish question number 4. And question number 5, M and N are the midpoint of CD and FE. A point P now is moving inside the rectangle. Okay, it's also inside the rectangle. It's equal distance from M and line segment FE. So it's 1 point M. So here, and 1 line segment. So it should be a parabola. And the point M here and FE is below it, so it should be a curve open upward. So I draw it like this. So this is the locus of P. So how can I describe it? The first one is a parabola inside rectangle ACDEF. This is the first one, and the second one is open upward with endpoint, because we have endpoint C and D. Okay, we finished the first one, number 5. And the last question is, okay, now it's also M and N midpoint, and point P is inside rectangle and is equal distance from M and line segment WX. So M is here and WX is here. So it will become a case. The line here, WX, is 1 line and the point M is 1 point. So it should be the open downward. So how can I draw it? It's like this. So it should be the first one is locus of. The first point is the parabola inside WZXY. The second point is open downward with endpoint Z and Y. So that's the end of question number 6. So in this worksheet, you need to distinguish there are 3 cases. Okay, the first case is 2 parallel line, and second case is 2 not parallel line, And third case is 1 point plus 1 line. So for the first one, it should be a point line between two parallel lines, and the second one is an angle bisector. Okay, it's an angle bisector. And the third one, it should be a two case. You have one case here, and second case is here. It's a parabola which is open upward.